uses of Laplace transform. So here I am going to apply Laplace transform to find the solution of second order linear differential equation with constant coefficients. So these are the process I am going to apply. Suppose if you take a ordinary differential equation with the initial conditions, I am going to take a Laplace transform on both sides. After applying some derivative formula, you may get the algebraic form. From that, I am going to apply inverse Laplace transform. From that, you may get the normal equation. That means solution of ordinary differential equation. So in this case, I am going to apply Laplace transform as well as inverse Laplace transform also. So if you want to change ordinary differential equation to algebraic form, you have to use this formula. So Laplace transform of derivatives I am going to apply. So here you must know what is independent variable and dependent variable. So here t is the time is a independent variable, but the variable y as a independent variable. Depending upon the problem, the notation for a dependent variable should be varied. Instead of y, they will give x, y, u, like that they will give. But you can apply the same formula. You have to apply correctly. So in this formula, I have taken y as a dependent variable, t as a independent variable. That means y depends on the time t. Next one. Problem number 1. Solve the second order differential equation given that x is equal to 0, dx by dt equal to 5 for t equal to 0 using Laplace transform. Sometimes instead of this ordinary differential equation, they will give like this: x double dash minus 3x dash plus 2x equal to 2. So like that they will give. Sometimes we can write the same equation as d square minus 3d plus 2 into x equal to 2. Like that sometimes they may give the differential equation, but we are using the same methodology to solve these three equations. The initial condition is x is equal to 0, dx by dt equal to 5 for t equal to 0. That is, you can rewrite the initial condition as x of 0 equal to 0, x dash of 0 equal to 5. This is the meaning. So in this problem, it is given that at t equal to 0, x is equal to 0 and dx by dt equal to 5. So that thing I have written differently. That means x of 0 equal to 0, x dash of 0 equal to 5. Now I am going to take this form of differential equation. Solution: given that d square x by dt square minus 3 dx by dt plus 2x equal to 2. We can rewrite this term as x double dash of t. No need to put t, but here I have used dx dash of t plus 2 x of t, because x depends on t. That's why I have specified here 2. Now I am going to take L of Laplace transform on both sides. Now I'm going to apply linear property of a Laplace transform. That means you can take Laplace transform individually. So L of 2 is equal to, we don't know about the value of L of 2. Better you can rewrite L of 2 as 2 into L of 1. L of 1 is nothing but 1 by s. So the Laplace transform of 2 is 2 by s. Now I am going to apply the formula Laplace transform of derivative. If you apply, you may get s square into L of x of t minus s into x of 0 minus x dash of 0. So instead of first term, I have used the formula. Similarly, you have to use the formula for second term also, because first two terms are a derivative. We are finding Laplace transform derivative, so that's why I have applied the formula. So if you apply the formula for second term, you may get minus 3 into s L of x of t minus x of 0 plus 2 into L of x of t equal to 2 by s. So by using initial condition, you can apply x of 0 is going to be 0, but x dash of 0 is going to be 5. If you apply initial conditions, you may get, after substituting the initial conditions, you may get s square into L of x of t minus 5 minus 3 into s L of x of t plus 2 into L of x of t, which is equal to 2 by s. So among 4 terms, these 3 terms have L of x of t. So for that, you can shift this minus 5 to right hand side. In the remaining terms, you have to take L of x of t as a common term, which is equal to s square. If you take as a common term, directly I am writing this step. L of x of t equal to 2 by s plus 5. If you take LCM, you may get 2 plus 5s divided by s. Now you can multiply. Our aim is, we want to find x of t. This is the normal equation. This is the solution for this differential equation. So better you keep L of x of t in the left hand side. Remaining term you have to shift to right hand side. This term is going to be divided by the corresponding right hand side. That means you can rewrite s square minus 3s plus 2. So L of x of t equal to 5s plus 2 divided by, you can factorize this term. So s into, if you factorize, you may get s minus 1, s minus 2. Now I am going to shift L to the left hand side, right hand side. From that you will get x of t equal to L inverse of 5s plus 2 divided by s into s minus 1, s minus 2. So we can't find L inverse directly. Now I am going to apply partial fraction. By using the partial fraction, I am going to rewrite sum of unique factor in the denominator. After that, you can easily take L inverse. So here I am going to take this is equation 1. Consider the term 5s plus 2 divided by s into s minus 1 s minus 2. So here in the denominator we have 3 different factor. So for that I am going to take like this. Now I am going to find a. By using Heaviside method, you can write 5s plus 2 divided by s minus 1 s minus 2. After writing this, you have to substitute s is equal to 0. From that you may get 2 by minus 2 minus 1, which is equal to 1. B equal to 5s plus 2 divided by s into s minus 2. Put s is equal to 1. If you substitute s is equal to 1, you may get 7 by minus 1, which is equal to minus 7. C equal to 5s plus 2 divided by s into s minus 1. S equal to, you have to put 2, which is equal to 12 by 2, which is equal to 6. After finding ABC, try to substitute that value in the equation 2. So now try to substitute equation 2 in equation 1. From that we will get x of t equal to a by s plus b by s minus 1 plus c by s minus 2, which is equal to a into L inverse of 1 by s plus b into L inverse of 1 by s minus 1 plus c into L inverse of 1 by s minus 2. If you substitute the value of a, b and c, from that you will get a is equal to a equal to 1, b equal to minus 7, c equal to 6. So L inverse of 1 by s minus 7 into L inverse of 1 by s minus 1 plus 6 into L inverse of 1 by s minus 2. By using this formula, we know that L inverse of 1 by s minus a equal to e power a t. So L inverse of 1 by s equal to 1. If you apply, you may get, by using these two formula, you will get 1 minus 7 into e power t 1 into t plus 6 into e power 2t, which is equal to 1 minus 7 e power t plus 6 e power 2t. Second problem, solve d square y by dt square plus 4y equal to sin 2t, given that y of 0 equal to 3 and y dash of 0 equal to 4. Solution, given that y double dash of t plus 4y equal to sin 2t, I am going to take a Laplace transform on both sides. If you take Laplace transform, you may get L of y double dash of t plus 4 into L of y of t equal to L of sin 2t. By applying the formula for Laplace transform or derivative, you make it s square L of y of t minus s into y of 0 minus y dash of 0 plus 4 into L of y of t equal to L of sin 2t equal to 2 by s square plus 4. We know the value of y of 0 and y dash of 0. This value is equal to 3 and y dash of 0 equal to 4. I am going to substitute the initial conditions. From that you may get s square L of y of t minus s3s minus 4 plus 4 into L of y of t equal to 2 by s square plus 4. I am going to shift this term to right hand side. From that you will get s square L of y of t plus 4 into L of y of t equal to 2 by s square plus 4 plus 3s plus 4. Now left hand side you can take L of y of t as a common term. So s square plus 4 into L of y of t equal to 2 by s square plus 4 plus 3s plus 4. Our aim is to find y of t. So you can shift this term to right hand side. That means you have to divide s square plus 4 in the entire expression, which is equal to L of y of t equal to 2 by, if you multiply you may get s square plus 4 whole power 2 plus 3s by s square plus 4 plus 4 by s square plus 4. That means I have divided L of y of t equal to 1 by s square plus 4 in the right hand side. After the simplification you may get this step. If you shift L to the left hand side, right hand side, you may get an inverse. You are going to apply the inverse. This is the meaning. In this part I am going to apply these three formulas in the right hand side. So you may get y of t equal to, by using linear property you may write directly 1 by s square plus 2 square whole square plus 3 into L inverse of s by s square plus 2 square plus 2 into L inverse of 2 by s square plus 2 square. So now try to apply this formula. Before that, in the first term try to identify what is a. So a is nothing but 2. So if you apply a equal to in this expression you may get the result for L inverse of this function. So from that you may get 2 by 2 into 2 power 3 sin 2t minus 2t cos 2t plus 3 into, by using third result you may get cos 2t plus 2 into, by using second result, sin 2t. You can cancel this term. 1 by 8 sin 2t minus 2t cos 2t plus 3 cos 2t plus 2 sin 2t. If you multiply 1 by 8 in this close bracket you will get 1 by 8 sin 2t. I am writing here 2 sin 2t minus 1 by 4 t cos 2t plus 3 cos 2t. Here you can add these two terms. If you add you may get 17 by 8 sin 2t. In these two terms we can't add because this is not like terms. So better you can take sin cos 2t as a common term. If you take cos 2t as a common term, you may get 3 minus t by 4 into cos 2t. This is called y of t. Solve third order differential equation given initial conditions. Now I am going to take Laplace transform on both sides. So directly I am writing L of y double dash triple dash minus 3 into L of y double dash plus 3 into L of y dash minus L of y equal to L of e power t square e power t into t square. Now I am going to apply the formula for L of y double dash. It is nothing but s power 3 L of y minus s square y of 0 minus s y dash of 0 minus y double dash of 0. After that I am going to apply for the formula L of y double dash 3 into s square L of y minus s into y of 0 minus y dash of 0 plus 3 into, so instead of this term I am going to apply s into L of y minus y of 0 minus L of y equal to, if you find the Laplace transform of e power t into t square is nothing but instead of t you can apply s by s minus 1. That means L of t square. After substituting, finding Laplace transform, you have to substitute s by s minus 1. Now I am going to apply the initial conditions y of 0 equal to 1, y dash of 0 equal to 0, y double dash of 0 equal to minus 2. So from that this term it's going to be 0. The remaining terms y of 0 is equal to 1. This term it's going to be minus 2. Y of 0 equal to 1. This is equal to 1. So like this I have applied the initial conditions. After substituting you may get s power 3 L of y minus s square plus 2 minus 3 into s square L of y minus s plus 3 into s L of y minus 1 minus L of y equal to, if you find L of t square is nothing but 2 by s power 3. 2 by s power 3. After that you have to substitute s by s minus 1. Now I am going to multiply minus 3 in the corresponding close bracket. After simplifying you may get s power 3 L of y minus 3 s power 3 L of y plus 3 s L of y minus L of y minus s square plus 2 minus 3s minus 3 equal to 2 by s minus 1 whole power 3. Next one. So here from the first 4 terms L of y as a common term I have taken. Remaining term I am going to write s power 3 minus 3s square plus 3s minus 1 minus s square minus 3s. I think you may get minus of minus, it's going to be plus 3s minus 1 equal to 2 by s minus 1 whole power 3. Now I am going to shift this term to right hand side, which is equal to L of y into, you can rewrite this term as s minus 1 whole power 3. This term is called the expansion of s minus 1 whole power 3. So directly I am going to substitute this term. This is the formula for a minus b whole cube. A minus b whole cube. So directly I am applying, simplifying this term as s minus 1 whole power 3. So s minus 1 whole power 3 equal to 2 by s minus 1 whole power 3. If you shift the remaining term to right hand side, you may get s square minus 3s plus 1. So L of y equal to, if you divide this term to right hand side, you may get 1 by s minus 1 whole power 3 into 2 by s minus 1 whole power 3 plus s square minus 3s plus 1. If you divide, you may get 1 by, that means 2 by s minus 1 whole power 6 plus s square minus 3s plus 1 divided by s minus 1 whole power 3. Our aim is, you want to find y. So if you shift this L to right hand side, you will get y equal to, that means you can write y of t, because y is a function of t. L inverse of 2 by s minus 1 whole power 6 plus L inverse of s square minus 3s plus 1 divided by s minus 1 whole power 3. Now I am going to find L inverse by using the property. The property is, suppose if you have L inverse of 1 by s minus a whole power n is coming, means you can apply e power plus at into L inverse of 1 by s power n. By using this formula, you may get e power t L inverse of 2 by s power 6. Here, if you apply the same logic, better try to write the term s should be s minus 1, s minus 1. So for that, now I am going to rewrite this term as, I am going to rewrite L inverse of s square minus 2s plus 1 minus s divided by s minus 1 whole power 3. You can apply the formula a minus b whole square here. So s square minus 2s plus 1 as s minus 1 whole square. So instead of this term, I am going to apply. And also, I am going to substitute the formula here. So what are the formulas I am going to apply? Before substituting, I am going to write, which is equal to e power t 2 into, I am going to apply this formula. L inverse of 1 by s power n is equal to t power n minus 1 divided by n minus 1 factorial, which is equal to t power 5 divided by 5 factorial plus L inverse of s minus 1 whole square minus s divided by s minus 1 whole power 3, which is equal to, if you simplify the first term, you may get t e power t power 5 divided by 60, which is equal to e power t power 5 divided by 60 plus, I am going to rewrite s minus 1 whole square divided by s minus 1 whole power 3 minus s divided by s minus 1 whole power 3. So in the first term I have taken L inverse, but I didn't take L inverse in the remaining terms. So you have to include L inverse, which is equal to e power t power 5 divided by 60. If you divide, you may get L inverse of 1 by s minus 1 minus, here you can rewrite minus 1 plus 1 like this. Again you can split the term. So you can rewrite L inverse of s minus 1 divided by s minus 1 whole power 3 plus 1 by s minus 1 whole power 3, which is equal to e power t power 5 divided by 60. This value is nothing but e power t minus, so if you cancel, you may get L inverse of 1 by s minus 1 whole power 2 minus, the minus is common for these two terms, so you have to multiply minus in the inside the close bracket. So L inverse of 1 by s minus 1 whole power 3. By applying the formula, first shifting the property, and as well as 1 by L inverse of 1 by s power n formula, you may get e power t power 5 divided by 60 plus e power t minus t e power t minus e power t square divided by 2. So this is called y of t. Solve this differential equation given that y of 0 equal to 1, y of pi by 2 equal to minus 1. So here the condition is boundary condition, it's not an initial condition. So 0 is a starting point. So y of 0, y dash of 0 is given, means this is called a initial condition, but y of 0 and y of pi by 2 is given. So this question is boundary value problem. So now I am going to find the solution by using Laplace transform of this boundary value problem. So given that d square plus 9 into y cos 2t, you can rewrite as y double dash plus 9y equal to cos 2t. Now I am taking Laplace transform on both sides. L of y double dash of t plus 9 into L of y of t equal to L of cos 2t. If you apply the property, you may get s square L of y of t minus s into y of 0 minus y dash of 0 plus 9 L of y of t. So this is the derivative. I have applied the formula for y double dash. No need to apply any formula for L of y of t. You take the same value equal to L of cos 2t equal to s by s square plus 2 square, that means 4. Now I am going to substitute the initial conditions, but only I have y of 0 equal to 1, but we don't know the value of y dash of 0. For that I am going to assume y dash of 0 equal to k. y dash of 0 equal to k. If you apply the initial conditions, you can get s square L of y of t plus y of 9 into L of y of t minus s into 1 is equal to s minus k equal to s by s square plus 4. So from the first two terms I am going to take L of y of t as a common. So s square plus 9 equal to s by s square plus 4. I have shifted this term to right hand side plus s plus k. So which is equal to L of y of t equal to s by, if you divide this term to right hand side, you may get s square plus 4 into s square plus 9 plus s by s square plus 9 plus k by s square plus 9. I am taking this is equation 1. So if you want to find L inverse, we can apply the formula easily for second and third term. But first term somewhat you have to do, then only you can apply the L inverse. 1 by 5 into 1 by s power 4 s power 2 plus 4 minus 1 by s power 2 plus 9. That means you can take 1 by s square plus 4 into s square plus 9 as 1 by 5 into 1 by s plus 4 s square plus 4 minus 1 by s square plus 9. Now I am going to apply this is, you can take this as the equation 1. From 1 implies y of L of y of t equal to s into, so instead of first term I am going to apply s by 5, 1 by s square plus 4 minus 1 by s square plus 9 plus s by s square plus 9 plus k by s square plus 9. Try to multiply s by 5 in this close bracket. You may get 1 by 5 s by s square plus 4. If you take L inverse, you may get y of t equal to L inverse of, like this, you may get minus 1 by 5 L inverse of s by s square plus 9 plus L inverse of s by s square plus 9 plus k into L inverse of 1 by s square plus 9. So after applying the formula, you may get 1 by 5. You can use this formula, L inverse of s by s square plus a square equal to cos at. You may get, by using this formula, cos 2t minus 1 by 5 cos 3t plus cos 3t. But here in numerator you have a 1. So you have to use this formula. L inverse of s by s square, that means 1 by s square plus a square equal to 1 by a sin at. If you apply the formula, you may get plus k by 3. So here 9 is there. So 9 you have to write 3 square. So a is 3. So k by 3 sin 3t. This is y of t. So here the solution is not the problem is not completed, because we are substituting k. But you must find, with the help of the given conditions, try to find out k also. So now I am going to find out the k value. Here you can add these two terms, because this is like terms. You can add these two terms. From that you will get y of t equal to 1 by 5 cos 2t plus 4 by 5 cos 3t plus k by 3 sin 3t. So this is equation 3. Now I am going to apply the boundary condition. That means y of, also given that y of pi by 2 equal to minus 1. Now I am going to substitute t equal to pi by 2. If you apply t equal to pi by 2 in the third equation, you may get y of pi by 2 equal to 1 by 5 cos pi plus 4 by pi 5 cos 3 pi by 2 plus k by 3 sin 3 pi by 2. So this value is equal to minus 1. Cos pi is equal to minus 1. So minus 1 by 5 cos pi by 2 cos 3 pi by 2 cos 5 by 2 is also is going to be 0. So this term it's going to be 0, but this value is going to be minus 1. So you may get 0 minus k by 3. If you equating, you may get k by 3 plus 1 by 5 equal to 1. K by 3 equal to, if you subtract, you may get 4 by 5. So k equal to 12 by 5. After finding k, you have to substitute in equation 3. So from 3 implies y of t equal to 1 by 5 cos 2t plus 4 by 5 cos 3t plus, already 1 3 is there. So if you divide, you may get 4 by 5 sin 3t.